everybody, this is Sam from Developing Mathematical Thinking, and today we're going to look at a concept that was actually really difficult for me to learn when I was a teacher, and that is the two different types of division context. So there's two problem types for division, and we'll go through some examples, talk about how to make these a little more sensible for learners, and then at the end I want to show you an example of why knowing these two problem types are so important when it comes time to learn about dividing with fractions. Okay, so we're going to start first with some pretty simple examples, just because the math is not what we're worried about today. It's really just the structure of these different contexts. So the first one we're going to learn about is measurement division. Now that's the teacher name for it. Kids often learn it as number of groups unknown. That's a real common one. There's another term you might hear called quotative. Some books describe it as quotative division. But basically, it's a situation where you have a known total, and then you're going to pull out a known measure some unknown amount of time. So let me give you an example. Let's start with 12 kids. So there's 12 kids, and then we're going to have 4 kids in a car. Okay, so 12 kids stand up in a line, and 4 kids are going to go to each car. And what we're going to figure out is how many cars there are. So if you were to give this problem to a young student who doesn't necessarily know any division techniques, usually what they'll do is model it with a physical enactive model, or they'll draw an iconic visual picture. So let me just draw kind of an informal diagram of what kids often do. So we've got our 12 kids, and then young students are going to figure out, okay, there's 1 car, there's 2 cars, there's 3 cars, and that's how they would solve the problem. Now, in 3rd grade, one of the most powerful tools for learning to divide is the ratio table, and we have another video on some different models and methods for division that explore this in a lot more in depth. So for this one, I'm just going to do a quick example here because it's going to help understand the other type of division. So in the table, I'm going to say the top part is the number of cars, and then the bottom is the number of kids. Now in the story, because it's measurement division, we're given a known measure. So we're going to just pull out 4 kids at a time, just like we did in this informal model here. And so what we're going to say is if we take 4 kids, that's going to use 1 car. Now, if the numbers were larger, we could work around the table, but for right now, I'm just going to go one by one and say, okay, there's now 2 cars would use up 8 total kids. And then to get to the total of 12, it's going to take 3 cars. And that's how students would typically attack a problem like this when they're first learning division around like 3rd grade. Or when they're much younger, they could probably use the model like I did. So that's measurement division. So now let's look at the other kind of division, which is typically called partitive. Now it's a fair sharing idea where you're going to be dealing out to a known number of groups. So another phrase you might hear kids describe this as, instead of partitive, because that's more of a teacher term, you might hear kids say fair sharing division or group size unknown, because that's what we're going to determine. So we're going to start with the same setup, that we've got the 12 kids, but now we're still going to keep the 4 in the problem. So essentially both of these are dealing with the idea of what is 12 divided by 4. But in the problem context, in the real world example, that 4 means something totally different when we move to partitive. So in this case, the 4 is actually going to be 4 cars. And the question is going to be, if we have to share the 12 kids fairly to 4 cars, how many kids will be in each car? So notice that in this last problem, the measurement, we actually knew that there were 4 kids in a car, but we didn't know how many cars there were. In this case, we're given the number of cars, the number of groups, but the size or the measure of each of those groups is unknown. So we're going to have to try to figure a way to solve this. And if you give this problem to a young student, they typically do things like draw the 4 cars, So I've got my 4 cars, not the best picture of cars, but just a simple model. And then I want to show you how the table and the way kids typically solve this informally actually help us understand the difference between these two problem types. So I'm going to actually start the table, but I'm not going to put the labels in just yet, because that will help clarify how partitive is different than measurement. So a young student would typically have the 4 cars out, and then just like dealing out cards in a game, we would just deal out kids to each car. So now I'm going to put some numbers in the table, but I want you to be thinking about what these numbers might mean. So we have 1 and 4. A lot of people will say that that 4 is the number of cars because that's what's given in the problem. But it's actually going to be something different. So watch what happens as we follow what a young student would do, which is dole out another kid. So now what would go in the table is 2 and 8. And why that is because this number on the bottom of the table is actually the total of kids. And the top part of the table is kids in a car, or each car, or per car. So now I haven't used up all the 12, so I'm going to go back out and part out that total. That means that if I put 3 kids in each car, that gives me a total of 12 kids. So the end result is we still get a quotient of 3, but depending on which problem type we dealt with, it means the 3 means something different. So we're going to go into some more examples here in part 2, where we talk about some fractions, but that's the basic difference between measurement and partitive division context.